Hello, my dear students. It's the next part of our paper, which is summer 24 P21. And this is question number 11 now. We are going to continue. I hope that you have watched my previous video in which we have solved the questions from question number 1 till question number 10. And now we are going to continue from here. It's from question number 11 till 20, inshallah. So in question number 11, they are saying that which graph shows the relationship between the pressure and volume of a fixed mass of a gas at constant temperature. And we know that the relationship between pressure and volume is inverse. They are inversely related to each other, right? So if the two quantities are inversely proportional to each other, then they don't have a straight line graph. So when one increases, it means that other decreases, right? So it's like that. So if we are going to take a look on ABC graph shapes. So if we are increasing one thing, another will not decrease. So we are having this shape that when pressure keeps on decreasing, then volume keeps on increasing. So here pressure is decreasing and volume keeps on increasing. So this is the best answer in this graph. Next question. During evaporation of a liquid, the most energetic particles escape. The temperature of the remaining liquid changes. Which row identifies where these particles escape from and describes the temperature change? Um, in evaporation, what happens that most energetic particles, they will leave from the surface. Okay, they will escape from the surface. So they are taking maximum of the energy with them because they are having more energetic. And they are leaving behind the particles which are less energetic. In this case, temperature keeps on decreasing, right? So if we will see from here, the place from which the particles escape, that should be at the surface because evaporation only occurs at the surface. So we have C and D options, but between these two, we need to check that temperature of the remaining liquid. What was that? It keeps on increasing or decreasing. So we will see that it decreases as from here. So C option, and it is correct. Okay, moving on to the next question. Question number 13. Wet cloths are put out on a line to allow the water in the cloths to evaporate. These are the wet cloths, and they are going to definitely allow the water vapors to evaporate. So, which type of weather would cause the water to evaporate most quickly? So, what are the factors which affect the evaporation? These factors include the high temperature. High temperature increases the rate of evaporation. More wind can increase the rate of evaporation. More surface area is also needed for it, and drought is also important. So according to the given conditions, if you will see here, they are just explaining the temperature, like here in these options, temperature and wind. These two things are there, and both of them should be present there to increase the evaporation rate. So how to increase it? Here, if you will see, that is the D option. A hot day with wind can increase the evaporation rate. So that is the D option only. Okay. Next question. Question number 15. A solar water heater is designed to absorb energy from sunlight. That is solar water heater, and they will absorb the energy from sunlight. Which surface texture and color would be the best for solar water heater? We need to absorb as many radiations as possible. So for this reason, we need the dull black surfaces because dull black surfaces are the good absorbers of the radiation. So A option, and it is correct. The next question. Which statement about waves is correct? If we will take a look on these options, they are talking about the transfer of energy and matter. First of all, the waves, they will just transfer the energy, but the matter will not transfer. As for example, if we are talking about sound waves, so when we are speaking, the matter itself will not move. Only the disturbance in the air molecules that will transfer from one place to another place, right? Even we know that the sound waves can travel in a solid medium and a liquid medium. So for transferring the energy, the matter itself, that solid or that liquid itself, will not start moving to transfer that energy. So waves can only transfer the energy, but the matter will stays the same. It will not changes its position. Only disturbance will be transferred from one place to another place. So for it, you can say that waves here in A option, they're saying waves do not transfer either energy or matter. It's wrong, totally wrong. Waves transfer both energy and matter. Again, they are saying that they are transferring the matter, which is the wrong option. Waves transfer energy without transferring matter. Yes, this one is our best option. Waves will not transfer the matter. It will just transfer the energy. The angle of incidence, next question number 17, the angle of incidence of a ray of light is incident of light incident on a plane mirror is gradually increased. Okay, like they are saying, for example, this is the plane mirror here, and here this is the incident ray. First of all, we should know that what is the angle of incidence. Angle of incidence is the angle between the normal and the incident ray, and angle of reflection is the angle between the normal and the reflected ray. So these two are the angles which they are talking about here, that the angle of incidence and angle of reflection. But what's the demand of the question now? To the nearest degree, what is the maximum possible angle between the incident and reflected ray? Like they want that you should tell the maximum angle between these two rays, incident ray and the reflected ray. So what should be the maximum possibility from here? It should not be zero, right? Because zero means that it is exactly on the normal, like that. No angle between ray and the normal. 45 means like both of them are very close to each other like this, then the total angle will be 45. 90 means that angle of incidence and angle of reflection both are at 45 and 45, then the total will be 90 degree. No, it is also not the maximum possible angle. So the maximum possible angle is D option, which is 180. It should be very close to it, like 89.99, like that you can say. So it's mostly closer to 180. The next question, which conditions are necessary for the light to be totally internally reflected? There are two conditions. One of them should be that the light should travel in the more dense medium. Okay. And the second condition is that the critical angle of incidence should be greater than critical angle. Okay. So these two are the conditions of the total internal reflection. If these two conditions will be fulfilled, then we can say that the light should be totally reflected. So here in these options, if we will see the more dense medium, incident light is in the more dense medium. These are the last two options, which is C and D, in which they are talking about that the light should be in the more dense medium, but in angle of incidence, it should not be less than critical angle. It should be greater than critical angle. So what is our best option in it? That is option number D. Okay. I hope that this question is very clear to you now. The diagram shows, question number 19, the diagram shows a ray of light passing through from air into a transparent substance. What is the refractive index of the transparent substance? So refractive index is actually what? Refractive index is n, and we know that its formula is sine of angle I over sine of angle R. Okay, like this is the angle of incidence and this is the angle of refraction. So when we are going to solve it, sine 40 degree over sine 30 degree, your answer will be 1.29, and that is B option. So it's very simple and easy question. Next question. Question number 20. The diagram shows a ray of light in an optical fiber. Which statement correctly explains the condition for the maximum transmission of light by the optical fiber? So they need that maximum transmission of light will be there in the optical fiber, right? Optical fiber is actually made up of a glass material. Okay. First of all, here they are talking about the critical angles. Okay. So critical angle for the optical fiber as large as possible, or critical angle for the fiber as small as possible. Okay, these two options are repeating once again here, large and critical angle for the fiber as small as possible. So we need to make the critical angle as small as possible for the maximum transmission. Okay, because at larger angle, the you can say that total internal reflection will be there. I cannot say this thing that total internal reflection is not happening at the larger angle, but the maximum transmission is possible at the smaller angle, right? So if we are selecting those options, then it includes option number D, and that includes option number B. So A and C will not be possible. Now, if we have to relate, the glass must slow the light, like speed they are talking about now. So how we are going to relate the speed with the critical angle now? You know that refractive index is equal to 1 over sine C. I have two equations for it. One is this one, another. Another is n is equals to speed of light in air over speed of light in glass. As I told you, that optical fiber is made up of glass, so I'm writing just medium here specifically. When we are going to equate these two equations, we have 1 over sine C equals to V in air over V in glass. I'm just going to rearrange this equation, and you will see from here, even if we are not rearranging it, that sine C is directly proportional to V in glass medium. Okay. So I'm writing here that sine C is directly proportional to V in glass medium. So as we are trying that our angle, critical angle should be as low as possible. So what happened that it should also slow down the speed. The glass must slow down the speed to make the critical angle as small as possible. Okay. So for this, we have D option, because from here it's the direct relationship. So we need this, like this option will be correct in it, but not this one, that as the glass must slow the light as little as possible. No, as much as possible. So if the critical angle will be lower, then the speed should also be lower in it. So from this concept, we can say that our D option is correct only, not B1. Thank you, students, for listening. For the next questions, you can please watch my next video. Thank you, and Allah Hafiz.